Hello everyone. Today we, group of two, Dushyant and Kanishk, are here to perform a mechanical operation experiment which is aimed to study the various bulk properties of powder sample. For this experiment we need two powder samples, brick powder, silica powder, a measuring cylinder, spatula and a weighing scale. The first step is to measure the weight of this measuring cylinder. After measuring the weight of empty measuring cylinder, we need to pour 30 ml of brick powder into the measuring cylinder. We need to measure the weight of this again. After measuring the weight of this measuring cylinder with brick powder up to 30 ml, now we will tap it 10 times on the floor. After tapping it 10 times, there will be a significant decrement in the volume of the powder. Then we will again tap it 10 times and there will be again a decrement. After each interval, we will note down the reading and we will keep doing this procedure unless the volume of the powder becomes constant. After making the observation table of number of tappings versus volume for the brick powder, now we will do the similar experiment for the silica powder. First, we will pour 30 ml of silica powder into the measuring cylinder. After filling it up to the 30 ml mark, we have measured the weight of cylinder with powder in it. Now we will start the tappings.
So as you have seen, we have performed an experiment for powder sampling for different bulk properties of a powder sample. Uh, for that, we have taken two different kind of substances. This is one is brick powder and another is silica. Uh, for After performing an experiment for both of the uh, powders, we have observed that after the number of several tappings, the volume of the powder becomes constant. As we have seen that uh, after zero tapping, their volume is 30, and after five intervals of tappings, we observe that the volume becomes constant. That is 26. So finally. Uh, we will finally find out the bulk density, and similarly we will find the tap density and true density and porosity for each of the uh, substance, each of the given readings. uh, for for doing this, we will firstly note down the weight of the empty cylinder, and the empty cylinder is weight is found to be 46.03 grams, and weight with sample, it is 83.12. So we will uh, subtract the weight of empty cylinder from the sample weight, and we will find the actual powder weight just subtracting. So uh, it comes out to be 37.09 grams. And the density of a brick is known, that is 2.26 to 22 grams per cc. And the bulk density, we will finally find out the bulk density of each a given sample. The bulk density formula is the actual weight of powder upon volume. Uh, so we will find out the bulk density of first sample, that comes out to be weight is 37.09 divided by the volume, that is 30. It is given that 30. So it comes out to be 1.236. Similarly, you can see that the bulk density of each center is, uh, is plotted in this table. That is, you can see that the tap density is weight of powder by constant volume after several tappings. And it comes out to be 1.4265 gram per cc. Now we will calculate the porosity of the substance, that is 1 minus E, and E is bulk density upon the true density of a substance. So for first reading, the bulk density is comes out to be 1.2236, and the true density is 2.22. So it comes out to be 0.4432. Similarly, we will calculate the other values. We have calculated the bulk density and porosity of the brick powder. Similarly, we will calculate the uh, bulk density and porosity of silica powder. So the readings for silica powder after several tappings, after 30 tappings, the volume becomes constant to 21, and we will finally found the bulk density and so we have found the bulk density and porosity of a silica powder as we have calculated the bulk density and porosity of a brick powder, and the weight of empty is cylinder is 45.6, and weight with sample is 62.9, and the weight of actual powder becomes 17.12 grams, and the density of silica is 2.334 gram per cc. Uh, so the calculated bulk density and porosity for silica is mentioned in this table. Now to conclude the flowability of two sample, that is one is brick powder and other is silica, we will finally compare them with Carr's index and Hausner ratio. It is given by volume of initial minus volume of after tapping divided by volume of initial multiplied by 100, and Hausner ratio is true density upon bulk density. For brick powder, we have found that HR is 1.15 and Cards index is 13.33 percentage. And similarly for silica, it is 1.421 and Cards index is 30. And we have the table of Hausner ratio and Cards index. And after that, we can finally conclude that the brick powder is freely flowing and the silica is poorly flowing.
Doing the calculation on paper in such an age of technology looks a bit tedious. So there is one more way to do the entire calculation in much simpler way in much lesser time. And you can just open a VS Code and write the following code. I can explain the code. In the first step, you need to import pandas library SPD. Then we will create a function. The name of function is properties. It will take four input: volume, mass of powder, true density. You can also give the input of number of tappings, but it is not necessary. Then we will create three empty lists: bulk density list, porosity list, and Hausner ratios list. Then we will do a for loop, such as for I in volume, bulk density. So what is bulk density? The bulk density is defined as the mass of powder, which is constant, divided by the volume. Then we will append the value of bulk density to the bulk density list. Then we will calculate porosity. So porosity is 1 minus bulk density upon true density. Then we will calculate Hausner ratio. Hausner ratio is mass of powder divided by final volume. final volume that is left after the tappings, that becomes constant, divided by bulk density. And then after calculating all these properties, we will calculate Carr's index, which is the final volume minus initial volume divided by initial volume multiplied by 100. We will add all this data to a data frame named as result. After creating the function successfully, we can enter the values. For example, the number of tappings. So for silica powder, the number of tappings were 0, 5, 10, 15, 20, 25 and 30. The volume was 30, 26, 24, 23, 22, 5, 22.5, 21 and 21. True density was 2.334. Mass of powder was 17.12. Then we will call the function. Similar thing can be done for the silica powder. The data for volume is entered here. Its true density, mass of powder, and then we have called the function. So let's run the code. If I run the code, you can see the entire calculation table, which mentions volume, bulk density, porosity, Hoshner ratio, and same for silica powder and brick powder. Now we can compare using Hoshner's ratio, which is more flowable. Clearly you can see the Hoshner ratio initially for brick powder was less than silica powder, which concludes that brick powder was more flowable.
For particle characterization, flowability is a very important property, and it can be used in various industries like food industry, pharmaceutical, and construction and agriculture. In pharmaceutical, it is used for filling of capsules and tablets, and in food industry it is used for filling milk powder, coffee or cocoa powder, and transport of these materials. And in agriculture, it is used in production of fertilizers